Lennox, a world leader in commercial HVAC systems and engineering excellence, 1995 National Quality Contractor of the Year, welcome you to the EOC program. The Equipment Operation Check is one of a suite of value-added products and services Lennox offers through its National Accounts Department. The EOC is the final step in the quality control process that begins with innovative design and ISO 9000 manufacturing. The EOC program assures customers who purchase equipment through Lennox National Accounts Department that their HVAC systems are properly installed and operating according to factory specifications. The keys to the success of this program are accurate data gathering by your skilled technicians and timely communications from your staff. First, let's look at how the steps are organized to provide the timely communications. The customer plans to build a store. The customer contracts with Lennox to furnish the HVAC equipment. Lennox ships the HVAC equipment to the installing contractor. Lennox sends a copy of the order, project schedule, and any special instructions to Engineering Excellence. Engineering Excellence selects a service provider and issues a purchase order to perform the EOC. The EOC service provider contacts the installing contractor to schedule the EOC. The installing contractor completes all phases of the installation. The service provider's technician completes the inspection. Data from the job is reviewed by the service manager. Data is sent to Engineering Excellence. Data is reviewed by Engineering Excellence, formatted, and sent to Lennox. When you receive an EOC purchase order from Engineering Excellence, we will advise you of the completion date. Your attention to this schedule is critical to the success of this program. Our goal is to have the EOC check run before the store opening date and to have all information transmitted to Lennox within 2 weeks of the store opening. This initial communication is important. We recommend that you refer to the letter sent with your purchase order for specific questions to ask the installing contractor. You will also want to call the installing contractor the day before your visit to the job to confirm that all items are complete and the equipment is ready for the EOC. This comprehensive checklist makes it easy to gather accurate data on the unit's operation. The Lennox IMC will help you to identify any problems with the equipment or the installation. Now let's review the steps necessary to conduct an EOC. We will demonstrate the process on an LGA 180. We encourage you to follow along on your checklist as you watch this video. The tools you will need are a digital multimeter, a digital ammeter, a manometer, refrigeration gauges, and hand tools. You will also need the Lennox manual on the integrated modular control, the service provider instructions, and a checklist for each unit. Record the control system information found on the DDC controller mounted inside the unit just to the left of the IMC board. The installing contractor should have painted the RTU number on or attached a nameplate with the RTU number to the unit. The electrical disconnect may be factory or field installed. Check the appropriate type. Check that a vented trap is installed on the condensate drain. The unit may include a convenience outlet. It must be field wired to 120 volts. If there is no outlet, check NA. Note and record fuel type. Check gas train unions with a wrench. On electric-only units, check NA. Visually inspect the belt tension and alignment. On multi-belt drives, check that all belts are installed. Visually inspect the filters. Burglar bars are installed in the ducts below the unit. You can determine if they are present by looking in the return air compartment on the unit. On certain accounts with burglar bars, a red warning label will be sent to you by Engineering Excellence. This label must be placed on the outside of the return air compartment door. Visually check if smoke detectors are present and wired. Do not test the smoke detectors. The following tests should not be done on units with DDC control. A feedback circuit will damage the DDC controller. Put a jumper on TB1 from terminal 3 to terminal 6. This will cause the indoor fan to run continuously. Put a jumper on TB1 from terminal 8 to terminal 9. This will cause the outside dampers to open to the minimum position when the unit is turned on. The presence of the jumper on terminals 8 and 9 is read when the disconnect is turned on. If this jumper is not present, the IMC will prevent the dampers from opening for 30 minutes during the first heating or cooling cycle. This board combines the function of many separate controls into an easy-to-understand, simple-to-operate integrated modular control, the IMC. The A55 board is the main board of the IMC. It has a single display push button, a 3-character LED readout, and 3 dip switches. The unit switch, SW1, the mode switch, SW2, and the address switch, SW3. Check that the settings on SW1 agree with the type of unit you are checking. Refer to the EOC instructions and the IMC manual for correct settings. Check that on SW2 all switches are off. Check that on SW3 the second switch is on and all others are off. To the left of the A55 board is the A59 board or the A61 board. The A59 board is used for gas or cooling-only units. The A61 board is used for heat pumps. Either board has a 2-position dip switch, SW1. This switch configures the system to the correct number of fans and compressors. Check that the settings agree with the unit configuration. After these checks are complete, turn on the electrical disconnect. The LED readout on the IMC will go through a self-test, flashing 888 on the display, and then go blank. This is the normal operation. Check that the heartbeat LED on each board is flashing steadily. If you don't have a normal flashing indication, contact Lennox National Accounts before proceeding. The first check using the IMC is to read and record the software version. Software version is displayed on the LED readout by placing switch 1 on SW2 on, then placing switch 2 on SW2 on. Return these switches to off after the software version is recorded. Measure crankcase heater amps at the compressor. To test the compressors, the system must be placed in full cool. On the IMC board, place switch 3 on SW1 on, and place switch 1 on SW2 on. The switches must be operated in this order. The display should indicate C01. Press the display push button 2 1-second presses to advance to C11 on the LED readout. If you advance past C11, you may reverse the LED readout by pressing the push button 2 half-second presses for each step you wish to reverse. Now press and hold the display push button until periods appear in the LED readout. The indoor blower and all compressors should start. Verify correct indoor blower rotation. You must correct rotation if necessary before proceeding. If rotation must be corrected, do it at the main disconnect only. Do not change any wiring on the system contactors. Take amperage and pressure readings of each compressor. Take amperage readings of indoor blower. Be sure the blower door is closed when taking these readings. Take voltage readings while the compressors are running. Take control voltage readings at TB34 for transformer T1 and at TB35 for transformer T18. Turn the compressors and fan off by pressing the display push button until the periods on the LED readout disappear. The temperatures must be read and recorded within 60 seconds of turning the fan and compressors off. Place switch 4 on SW2 on. The LED readout will alternate between point 0 and the ambient air temperature. Record the ambient air temperature in space 51. Press the display push button once to advance to point 1. The LED readout will alternate between point 1 and the return air temperature. Record the return air temperature in space 52. Press the display push button once to advance to point 2. The LED readout will alternate between point 2 and the supply air temperature. Record the cooling supply air temperature in space 53. After recording the temperatures, place switch 4 on SW2 off. Place the system in full heat with the IMC board by placing switch 3 on SW1 on and placing switch 1 on SW2 on. The switches must be operated in this order. The display should indicate C01. Now press the display push button 5 1-second presses to advance to H11 on the LED readout. Remember that to reverse the readout, you press the display push button 2 half-second presses. Now press and hold the display push button until periods appear in the display. The indoor blower and all stages of heat should start. Check the gas line pressure at the 1/8-inch pipe tap installed upstream of the valve. If a tap is not available, remove the cap from the drip leg and temporarily install a reducer to connect your manometer or gauge. Measure the outlet pressure of each gas valve. Check the nameplate for the required gas manifold pressure. If pressure is different from the nameplate data, adjust the valve as required. Turn the gas valves and fan off by pressing the push button until the periods on the LED readout disappear. Now open the blower door and disconnect the fan power plug at the bulkhead connector. Close the blower door. Press and hold the display push button until the periods appear in the LED readout. The unit should start both stages of heat and, after a brief warm-up period, should shut off on high limit. Press and hold the display push button until the periods in the LED readout disappear. Use extreme caution. When the power plug is replaced, the fan will start. Be sure and keep hands, clothing, and tools clear of belts and pulleys. Now open the blower door and reconnect the fan power plug at the bulkhead connector. Close the blower door. Press and hold the display push button until the periods appear in the LED readout. The fan and both stages of heat should come on. Allow the heat to operate for 2 to 3 minutes before taking temperatures. Place switch 4 on SW2 on. The LED readout should alternate between point 0 and the ambient air temperature. Press the display push button twice to advance to point 2. The LED readout will alternate between point 2 and the supply air temperature. Record the heating supply temperature in space 54. After recording temperatures, place switch 4 on SW2 off. The following checks cover the optional outside air dampers and the economizer. There is a dip switch and 2 potentiometers on the A56 board that control the economizer. The dip switch on the A56 board selects the mode of operation. There are 4 modes of operation that can be set on the switch. Refer to the IMC manual for a discussion of these modes. The potentiometers on the A56 board are used for adjusting the damper minimum position and the enthalpy set points. You will have to change both the dip switch and 1 potentiometer to complete the checklist, so it is important to display and note the factory settings before proceeding. To display the minimum position setting, place switch 4 on SW2 on. The LED readout should alternate between point 0 and the ambient air temperature. Press the display push button 6 times to advance to point 6. The LED readout will alternate between point 6 and the minimum position setting. Note the minimum position setting. Place the A56 switches in the D-set position. Turn the minimum position potentiometer 100% clockwise and check that the outdoor dampers drive open. If the system has an exhaust blower, check that it started when the damper was 50% open and stopped as the damper closed. Turn the minimum position potentiometer counterclockwise to display the previously noted value in the LED readout. When adjusting the minimum position potentiometer, allow a few minutes for the value to stabilize. When the minimum position display is the same as originally noted, return the dip switch to the